All right, in this video, we are going to discuss thrust. But before we talk about thrust, we're going to move back a couple of lessons, and we're going to talk about lift. Remember, lift is that force that is produced by the dynamic effect of the air acting on the airfoil. Now, I wanted to come back and see that lift because I wanted to talk about airfoil. Airfoil is the shape of the wing that enables us to force the air over the wing and under the wing to create lift. And when we talk about airfoil, the reason we do that is if you take a look at this piece of paper and the way it sits, it would really just slice right through the air. There wouldn't be any lift created if this was our wing. But when we create an airfoil in this shape, now you can see that it resembles the cross section of our wing when we talked about lift. And the reason why we bring that in is because we're going to talk about thrust, and specifically we're using thrusts that we get from a propeller. And the way that they're the same is that the wing is actually designed as an airfoil. I said the wing, the propeller. The propeller is actually designed as an airfoil. So when we look at this piece of paper again, and that's the airfoil, I want you now to imagine that this is the propeller spinning. The propeller has a leading edge, just like the wing, and this tapered edge at the back. That occurs on the propeller the same way it does on a wing. So thrust is the forward force produced by the power plant, propeller, or rotor, and it opposes or overcomes the force of drag. That's thrust, which is the opposite of drag. Okay. So as a general rule of thumb, it acts parallel to the longitudinal axis, but that's not always the case. We're going to look primarily, to start with, at this single engine plane. The single engine plane has the two wings that we talked about here in lift, and it also has that same airfoil design on the propellers. So as we start the engine up, and the engine rotates the propellers, as that speed increases and that air passes over those propellers at a higher rate of speed. Remember when this one did that, when we're talking about the wing, we saw the aircraft oppose gravity and lift. And so that we were primarily thinking of the vertical axis. Well, here, now that we've taken these wing-shaped pieces, put them on the motor, we're now creating, that lift is now creating thrust, which is the opposite of drag, and will have a tendency to move our aircraft forward in the horizontal axis. So single plane using the propellers to create lift, pushing forward, which is thrust. We're going to look at that in a couple of different ways, although thrust is defined the same. Let's look at the jet engine. We won't get too much into the jet engine, but instead of any moving parts, you don't see any rotating parts. Those rotating parts are hidden inside the engines. So this is doing something a little bit different because it is burning air and fuel to create a force coming out of the back of the jet engines. That force is the thrust that allows this aircraft to go forward in the horizontal axis. So same principles, different ways of creating the power, creating the thrust. So helicopters. Same things with helicopters. Nice little helicopter. The blades here, the propellers on the helicopter, are also airfoils, and this one is unique because it has one on the back. So this helps the pilot create yaw. Still the same, lift is created, and force or thrust is created in the direction in which that blade is turning. Up here, this one has a tendency to spin around, and at its most level angle, the helicopter will create a vertical lift. Now it still can use movable flaps to make the aircraft move, but uniquely it also can tilt. Each one of these propellers can tilt and create thrust in a different direction. Here's a little bit easier way to see that. Even though this is an aircraft from fiction, it can still demonstrate the same thing. As we look at the propellers here that are spun by an engine or motor, there is vertical lift that raises the aircraft off the ground. When those engines are tilted, the thrust now changes. Instead of thrusting completely forward or up, it now has a pitched movement, and it's going to thrust in the direction to which those propellers are turned. So remember, thrust is overcoming drag. And regardless of how we change the aircraft, it's all the same. So finally, we end here with the drone. The drone has 4 propellers. 2 are spinning clockwise and 2 are spinning counterclockwise. They are still an airfoil, so they still create lift. And when we turn them on and power them all up at the same power, we get vertical lift. That vertical lift is created by thrust. So where in our aircrafts like this, we're trying to create lift over the wings, we're only utilizing the lift of the propellers that's creating thrust that brings our aircraft up. When we decrease power to the front motors and increase power to the back motors, our aircraft will pitch forward and we will have thrust in a forward direction. And same goes to decreasing right front and right back and increasing left front, left back. We get a right roll where now the aircraft has thrust in the right direction. That's simply all thrust is. Thrust is created by lift of the propeller. It opposes the forces of drag, and once you've opposed the force of drag, you now have thrust. So simply, that's what thrust is.